Okay. So 1.2, so now we're going to be doing square roots of non-perfect squares. Okay, so last time we were doing our perfect squares. So just as a little bit of review there. What is the square root of 16? Let's do hands, yeah. 4, yeah, right. So the square root of 16 is 4. Didn't even need a calculator for that, right? Because we know that 4 times 4 is equal to 16. So square roots are just going back the other way, right? Is all we're doing there. So now what this lesson is about is that what if I had the square root of 17? That's a non-perfect square, right? 16 was a perfect square because you take the square root and you got a nice number out of it. Square root of 17, can you guys actually just do that right now because so many of you have your calculator especially? Can you type in the square root of 17 and tell me what you get? 4.1234505626. Right. Anybody, oh good, I was going to ask. So anybody remember what kind of number that is? That's, what was it, Cooper? Irrational. Yeah, that's an irrational number, right? An irrational number is a number like pi where it just goes on forever. It never repeats. You're just going to get the string of random digits forever. Which is kind of weird in itself, isn't it? Like, isn't that a weird concept that if the length of this desk was an irrational number, that means I could you could never pinpoint it. It's like always going to be like no matter how accurate I get, I'm never going to get there. Like it's a weird concept, yeah. Oh, okay, but anyway, so if I took the square root of 17, we can kind of approximate these things. We can kind of get close to them, right? So what do you guys think? Does anyone have a guess? Like square root of 17, what would that be?
4.1 because it's 4.12 and 2 and 5 and you don't round it.
Right. And did you use your calculator to find that?
Yes.
Yeah. But what if you didn't have a calculator? Well, I know the square root of 16 is 4. So 4 and a little bit, right? It's kind of like that. So that's what we're going to be doing here. It's just 4.2. Yeah, well, it's be 4.1, right? 4.1. Yeah. So I'm not going to require that you guys get very accurate without a calculator, but to the 0.1, we should be able to be pretty close. So okay. Anyway. Okay, let's try this one. Oh, sorry. Back up one step here. This idea that I just had there, when we kind of estimate based on the square roots that we do know, it's called benchmarking. So here, I'm just going to pause this for a second. So it's the idea of using perfect squares we know as benchmarks. So I think where benchmarking comes from, quite often, do you guys, anyone do any construction stuff? Yeah, like construction, cutting wood, any parents doing that kind of stuff. So quite often what you'll do is you'll make a mark, when you're cutting wood, you'll make a mark, right? And that's called a benchmark, right? It's on the bench. We're going to mark on the bench, right? So then you can kind of go back and forth from that. So that's where it comes from. It means that we're using some measurements that we actually know to kind of guess at what the one we don't know is. Yeah, okay. So using this benchmarking idea without using a calculator, square root of 27. Square root of 27. Just taking the guess. If you want, remember, you got that up there. Look up there. 5.3. 5.3. Okay, so we got a 5.3. 5.2. Anyone else? Okay, try it out. What do you get? 5.1. Yeah. So let's to get a bit better, I think, guess on what's happened there. The two square roots we were looking at there were the square root of 25, and then what's the next one up?
36. Square
root of 36. And this one's the square root of 27, so I don't know if this is a number line here. Okay, so, and we were looking at the square root of 27. You can kind of see on the number line a little bit better there that the square root of 27 is pretty close to 25, right? And if this was 5, square root of 25 is 5, and this is 6, you can see that my answer must be 5.1 or 5, at most 5.2. It's not going to be 5 even 3 or 4, right? 5.3 or 4 would be over here or over here. Yeah? Okay, cool. So that's the idea. Okay, so we can do the same thing with fractions. So remember, fractions weren't too bad with square roots. Let's, as a bit of review here, what if we took the square root of 81 over 36? you remember how we did? Remember, like it's fractions, but it's not as complicated as we think. Yeah.
We just do, we square root 81 over 36.
Yeah. So what's the square root of 81?
9.
9. Yeah. 9 over 6. If you punch that into my open math, it would tell you that you didn't get it right. What should we do?
Simplify.
Simplify it. So
So you can go over 3.
right.
2. Oh,
Yeah.
3 over 2.
So 9 divided by 3 is 3. 6 divided by 3 is 2. Yep. So perfect. Okay, so yeah, good review. Now, let's say which of the following is the closest approximation of the square root of 17 over 10? So it seems like you'd be like lost, right? There's nothing we can even do here.
4.1. And then 10 would be like 3.1.
Okay, yeah. So some of you guys are figuring it out, right? But let's kind of just go step by step here. I don't know the square root of 17, and I don't know the square root of 10. So I'm going to use benchmarking, right? I'm going to start thinking, okay, what is a number close to 17 that I do know the square root of?
60. Are you gonna keep these up?
So yeah, sometimes I keep them up for a while, and actually like I'll cover it over with like a cloth or something later on. Yeah, for a test, yeah. But if you guys wanted to at the beginning of a test, why not just go like 2 squared, 3 squared, 4 squared? You can make your own pretty quick.
Are you allowing like cheat sheets kind of thing? Like if you were to write this all down in a notebook, would you be allowed to bring that notebook?
Well, it depends. If we were doing like a calculator version, then sure.
Okay.
If we were doing like a no calculator version, then probably not.
Okay.
Yeah. Okay, anyway. So what I'm going to do instead is I'm going to rewrite this fraction a little bit different. I'm going to write this as 16 over, and then 10. I don't know the square root of 10, but what's one I do know on there that's close to 10? Yeah, 9.
Would you just round it down by the time?
Yeah, and for the most part with fractions, they get a little bit, you know, like whether it's higher or lower than that. That's going to be good enough. If I just take the square root of this, then it's going to be square root of 16 is 4 over 3. And there you go. It's close to that. It won't be 4 over 3, right? Like it's a different fraction, but it'll be close, right? It's going to be in the same ballpark.
Well, it's 4.1 and 3.1. So.
Yeah, exactly. So yeah, it's pretty close. Yeah, so for the most part, that's it. All right, so this is actually a PAT question, right? This is the kind of question that you guys would get. It says, in estimating the square root of 127, which two perfect square numbers would provide the best two benchmarks to estimate your answer? So,
11.
okay, so what we would do is I'd be thinking, okay, 127. And again, this number line's handy, right? 127. It's in between.
11.3.
Right, and the question's really asking us.
2.
Yeah, the question's really asking us, like, which two numbers, which two perfect squares? If that's a perfect square, that's a perfect square. I'm going to use those two to estimate, right? Okay. Okay, so what was the answer then? It's going to be 121 and 144, right? Yeah. Okay. Number 4, determine what two whole numbers the radical is located between. So you haven't really seen the word radical. It's radicals. So a square root is a type of radical. And then next year we're going to be doing like cube roots, and you can do fourth roots and anything else, right? Those are all different types of radicals. So a square root is just a different type of radical, or like a specific kind. So square root is 61. All right, so do you guys remember these symbols too? Let's maybe do a review on that. Those symbols like right there, like what they mean.
The one pointing towards, like the arrow pointing towards that box, that means the number from the square root of 61 is greater than in that box.
Okay, yeah, good. Yeah, that's exactly right. So the way that works is if I had, let's say, 3 and then a symbol like this and then 4, that's saying that 4 is greater than 3. You could write it the other way too. It could be 4 is greater than 3. And one way to remember that is that if this was an alligator, it always wants to eat the bigger one.
Technically, with the alligator, you both
He can only choose one. He gets one meal.
Otherwise he gets struck by lightning.
Yeah, we're making up our own rules here. Yeah. It would also be true. So I could do this too. So you could say when I'm looking at this, this says 4 is greater than 3. But you can also read it as 3 is less than 4, right? Like either way, you can think about it. So, all right, so what this is saying then is that the square root of 61 is greater than some number, and the square root of 61 is less than this number. So like it's benchmarking. What two numbers is this thing between? So, yeah.
49 is lesser than 61, and 46 is greater than 61.
So sorry, what did you say?
7 and 8.
64 is greater than 61.
Right, okay. So,
You're doing square root. You're not doing. Oh,
actually, no, you're right.
what?
Okay, and the reason,
Because square root is 4 though.
right, because the square root of 61 is going to give me a number like 7 point something, right? That's what that is. This is like this number that's sitting there with the square root is 7 point something.
Yeah.
So the numbers I'm looking for are going to be 7, like not, so it'd be 49, it's going to be 7 and 8, right? The square root of this number is going to be like 7.8 or 7.9,
Okay.
right? Like this, you can replace that with 7.8 because it really is. Like when it's written with a square root, that's what the number is. Yeah.
Tucker Big Brain.
Okay, so sometimes we've been doing stuff with square root or Pythagorean theorem already, but sometimes when we use Pythagorean theorem, that very last step, you'll have to take the square root, on this last step there, and you're going to get an irrational number. So then, but what we can do, so let's say we got to this point and we saw that it was 128. Well, again, I can say, well, okay, square root of 11 is 121. Square root of 12 is 144. And I'm at 128, right? And sorry, so this would be like 11 and 12. So my answer here would be like 11.2. Yeah. So we can estimate it that way. So okay. Can you guys just do this question and that's it? And we're just gonna start doing. Yeah. So write the exact length with no decimals. So let's see what you guys get. So give it a try.
Sorry guys.
All right. If you're watching this after, follow along here.
I did some off camera.
Yeah. Sorry, guys.